Behind the splendor of the KAAN 5th generation fighter jet lies a highly complex and high-tech engine assembly process. The KAAN program, developed by Turkish Aerospace Industries, TAI, is Turkey's strategic project to create a modern stealth fighter capable of competing with world-class 5th generation fighters. A fighter jet engine is the heart of a fighter aircraft. Without a powerful, reliable, and efficient engine, the aircraft's maneuverability, speed, and combat effectiveness cannot be achieved to their full potential. In the early stages of development, the KAAN aircraft used the General Electric F110 engine, also used in various F-16 variants. This engine was chosen because of its proven high performance and allowed for faster aircraft development without having to wait for domestic engines to be developed. Within the KAAN production complex in Ankara, every engine component is assembled to stringent precision standards. The production area is equipped with a modern manufacturing system that utilizes industrial robots, high-precision CNC machines, digital sensors, and a computer-based quality control system. The assembly process begins with the installation of a high-pressure compressor, which compresses air before it enters the combustion chamber. Afterward, technicians install the combustion chamber, which is where the air and aviation fuel are mixed. Next, the turbine is gradually installed. The turbine is the component that captures the heat energy from combustion and converts it into rotational power to drive the compressor. Because it operates at extreme temperatures, the turbine blades are made of a special superalloy material that can withstand extremely high heat. The next stage is the installation of the afterburner system. This technology enables the engine to generate additional thrust when the aircraft requires maximum acceleration, such as during air combat or takeoff with a full load. The afterburner system is a key feature of modern fighter aircraft engines. Before the engine is installed on the aircraft, each unit must undergo a rigorous testing process. Technicians conduct vibration, pressure, and temperature tests, as well as simulate extreme flight conditions. The engine is housed in a special test chamber capable of simulating various operational conditions. After passing testing, the engine is transferred to the aircraft's final assembly line, FAL. At this facility, the fuselage, wings, avionics system, radar, and engine are combined into a single unified fighter platform. The integration process utilizes laser systems and digital tools to ensure the engine's precise alignment according to design specifications. This technology is crucial because even the slightest deviation can affect the aircraft's balance and aerodynamic performance. The assembly facility also houses a wind tunnel, a specialized paint facility, and a radar testing area used to verify the aircraft's stealth characteristics. This infrastructure demonstrates Turkey's commitment to building a self-sufficient ecosystem for producing modern fighter aircraft. The TF35000 engine symbolizes Turkey's ambition to achieve full self-sufficiency in military aviation technology. The development of this engine involves various national companies collaborating to produce an engine with a thrust of approximately 35,000 pounds force.